Good afternoon and welcome to the webinar introducing BG50, the latest edition published in 2021 on water treatment for closed heating and cooling systems. My name is David Bleicher. I am BSRIA's Publication Manager, so I am the editor and publisher of BG50. Just a few notes. First of all, we are recording this webinar. You are going to receive a PDF of the slides and a recording of the presentation, and also people who weren't able to make it today are also able to request a PDF of the slides and a recording of the presentation. We do have rather a lot of people here. We have 79 attendees at the moment. So unfortunately, I'm not going to be able to unmute you. That could get difficult to manage with so many people. So if you do have any questions, pop them in the question box. I'm going to try and keep an eye on the questions box as we're going through the presentation, and I will either answer the questions as I go along or attempt to answer them once I get to a convenient place, maybe at the end of the webinar or maybe at the end of a slide or something like that. With me today, I also have Dr. Pamela Simpson. She is the author of the guide, and she may be able to answer some of the technical questions that I'm not able to answer as the editor of the guide, but I'll certainly do my best to answer all of those as we go through. So first of all, I'm going to start out just by defining water treatment, because there is a little bit of confusion over this. I think traditionally people have thought that water treatment only means chemical water treatment. Here we're talking about the much broader topic of water treatment, and there are a number of techniques that can be used to improve the quality of water so that it's appropriate for its intended use. In this context, we're talking specifically about closed systems. So we're talking about any of these technologies that can be used to make sure that we don't get problems like corrosion in closed systems. As we go through, I'll talk a little bit more about each of these techniques that can be used for water treatment in closed systems. And just to set the context, this is why we need some form of water treatment, whatever form that is, in any system. The first and most obvious reason is oxygen corrosion. And to put it in a very basic scientific fashion, water plus oxygen plus iron is going to give you corrosion. Same applies to some other metals as well. So here we've got an example of a shell and tube heat exchanger that appears to have had quite a lot of corrosion on the shell and the tubes themselves. But it's not the only form of corrosion you could get. There's actually a lot of different forms of corrosion. One of them that is a particular concern in closed heating and cooling systems is microbiologically influenced corrosion, which we have shortened to MIC in the guide. You might see other terms for it. You might see it sometimes called bacteriologically influenced corrosion. It's all the same thing. And these pictures that here, these are actually screenshots from case studies in the guide, and they're taken from investigations that BSRIA staff or people on the BG50 steering group have carried out, in which they've identified what has actually caused pipes to fail. So with microbiologically influenced corrosion, what you tend to get is a buildup of what we call a biofilm, and then you get bacteria that literally eat away at the inside of the pipe. Other problems that you can get if you don't get the water treatment right. One of them is scaling. I'll try and explain what's going on in this picture on the left. It might not be immediately obvious. This is a single plate from a plate heat exchanger. So normally in a plate heat exchanger, there's multiple plates stacked up against one another that produce a number of passages between those plates. But because those passages are quite narrow, if there is an excess of certain chemicals in the water, you can get a buildup of what we call limescale. Limescale isn't the only form of scale, but it is certainly a very common one. So here what you're seeing is virtually the entire passages have been blocked up with limescale. That reduces the efficiency of the system. It means that because the passages are smaller, the pump will have to work harder to push water through them. Eventually it will get blocked altogether. Long before it does, the effectiveness of heat exchange will be very much reduced. Another problem that you sometimes get is stress corrosion cracking. This is something specifically that happens on brass components as a combination of stresses that might be caused by over tightening of pipes, or perhaps stresses in the supports of the pipework, and that's combined with corrosion of the pipes. So these are just some of the problems that can occur, but by no means all of the problems that can occur if you don't get the water treatment right. I'll now talk a little bit about the history of BG50, of how we got to where we are today. So back in the 90s, long before I was at BSRIA, we had a guide, AG293. So 93 is the year that it was published. And it covered the more general topic of water treatment in building services systems. It did cover closed systems, but it also covered other systems such as open systems, hot and cold water, swimming pools. It was a relatively short guide compared with what we have now, and because it was covering a number of topics, none of these were covered in great depth. So yeah, that was around, that was actually a current publication for around 20 years, but we did withdraw it once BG50 was published, so simply because BG50 covered closed systems, and by that point, other guidance had been published by other organisations on water treatment of other types of systems. So in starting around 2011, we identified that AG293 was getting very old and that it didn't adequately cover the main issue that we were getting inquiries about, which was closed heating and cooling systems. So we formed a steering group, an industry-wide steering group that was a joint venture with a number of other organisations, many of whom are still involved with BG50 today. It was written actually by a number of authors. Different authors wrote different sections, and those were edited by Reginald Brown, who some of you may remember, who sadly passed away since he worked on this guide. So yeah, it's going into much greater depth on water treatment for closed heating and cooling systems. And also at the time, this was published about a year after a major update to BG29. So we had made sure that it was aligned with the 2012 edition of BG29 and also with BS552, which again was fairly new at the time. This is now a superseded publication though, because now we have BG50 2021. So this is the second edition of BG50. There's a number of reasons why we've updated it. First of all, to align with BG29, which was published. Actually, BG29, we did have a 2020 edition, but we then made some changes to that. So there is also a 2021 edition of BG29, which came out about, I think it was April this year. In addition to that, we've covered some additional technologies and techniques that were not covered in the previous edition of BG50. It was authored by Dr. Pamela Simpson, who we have here today, and this was published almost 2 months ago now. It was around the beginning of October 2021. I'll tell you a little bit about how we actually went about authoring this. First of all, we had a steering group, and this started around January 2021. That was the point at which we formally commenced meetings of the steering group and also appointed Dr. Pamela Simpson as author. There were two chairs of the steering group. There was myself, and there was also John Smith of the Closed Systems Control Association. I believe John is not on the call today. So we kind of took it in turns to chair the meetings. There were a lot of meetings, and rightly so. There was a lot to discuss. We really did go into detail about every section of the guide. We had a lot of subgroup meetings because there were certain topics that only certain people on the steering group had interest in or expertise in. Of course, these all took place online. When we started this, we were still in lockdown, and even later on, we found that it was very convenient, and we were all used to meeting online. But by this point, the makeup of the steering group did change a little bit, mainly because we needed additional expertise in certain areas. eventually we had a total of 25 people on the steering group. It was quite a large steering group, so that's why it was necessary to have so many meetings. Not necessarily everybody was at every one of these online meetings though. Also, we did this in association with a number of partner organisations. These are, if I just go back a few slides, you can see we've got the logos of the partner organisations on the front cover of the guide. So each of these partner organisations were represented on the steering group. Also, these organisations have been very helpful in the past few weeks with helping us spread the word about the guide, and sometimes even doing their own webinars. So as I've been speaking, I have seen some questions coming in. I'm going to have a quick look of these at this. All right, these are quite technical questions that I'm probably not going to be able to answer on the spot. So Paul, I will get back to you on that one. Engin, apologies if I have your name wrong, Engin. You've talked about plastic pipework there. That's a very interesting one, because plastic pipework doesn't undergo corrosion per se, but it does undergo chemical attack, and certain types of plastic pipework are particularly susceptible with certain water chemistries, and particularly they need to be compatible with the any water treatment chemicals that are used. If you are using water treatment chemicals, they also need to be compatible with metals on the system. I believe there is one particular type of plastic, and I can't remember which, that has that sometimes runs into issues when you also have copper in the system. I will try and provide you with some more information about that though, Engin. What would be really great is Paul and Engin, if you could both email me with your question, so that I can give you a full response to those. The next question that has come in is about VDI 2035. So I may as well answer this question while I'm here. So what we found during the authoring of this guide, and also the authoring of BG29 that came before it, is yeah, there are a lot of manufacturers who are now specifying VDI 2035, but also there's a lot of other guidelines out there coming from various countries. We tried to list them. We found out there's actually quite a lot. Yes, VDI 2035 is a very well-known one, but it is by no means the only one. So we have referred to these collectively in BG50 as non-UK guidelines. All we have said about non-UK guidelines is that we recommend, if anyone is asked to conform to non-UK guidelines, first of all, they get hold of those guidelines and they make sure they understand them. And second, that they seek advice from people who are specialists in the guidelines themselves, and also in any equipment that is specifically designed to work with those guidelines. Now, in the fullness of time, this may change. We might find that we are able to publish specific guidance on those non-UK guidelines, but that will probably involve some quite extensive research in how these guidelines really work with UK systems, because bear in mind, these are guidelines that are written in countries that have practices that are quite different from the UK. So translating them to UK practice isn't necessarily an easy thing to do. I'm not saying it's impossible. I'm saying that it will require some further research, and I would personally like to see that research done. Another question that was coming: can we all get to see the questions and particularly answers to these? I see no reason why not. I think the way that GoToWebinar works, we do actually get a question log, so we will record that and we will answer those and provide those to everybody. It probably won't be right away. We'll be able to send a PDF of the slides out right away. We'll be able to send a recording perhaps a little bit later, because it takes a while for the recording to process. Answering the questions is going to take us a little bit of time, but yes, we will do that, or at least we will do our best to answer every single question. Yes, and there's also the question about barrier pipework. We do mention plastic pipework in the guide. It's not that we don't mention it at all, it's that we don't have a specific extensive section on plastic pipework in the guide, we do definitely mention the issue of barrier pipework, because there are certain types of plastic pipework that permit oxygen ingress. Oxygen ingress is something incredibly important in closed systems. It's something I mentioned on some slides earlier. If you have oxygen getting into the system, then that would normally cause corrosion, and you would expect to have to do some form of water treatment to try and counteract that. But of course, rather than trying to counteract the any oxygen ingress you're getting, by far the best thing to do is avoid it in the first place. And this might involve using barrier pipework. Question about boron as an inhibitor. I can't answer that question, I'm afraid. I don't have the technical knowledge to do that. Perhaps somebody else might be able to answer that question before the end of the webinar. If not, it will be in the answers that get distributed after the webinar. Okay, back to what I was talking about how we produce the guide. So those are the partner organisations that helped us out immensely and were represented on the steering group. I'll also talk a little bit here about what the scope of BG50 is. So first of all, it is not a regulation. A lot of people get confused about this, and they think that it is mandatory to follow BG50, or that you know, there's a law somewhere saying that you must follow it. Not at all. It's a guide. It's a guidance document that we have published for people to help people manage their systems. From that perspective, it's optional, but it is quite often written into contracts that, for example, when a building is handed over, the guidelines of BG50 are followed, or that when a building is managed, the guidelines of BG50 are followed. So it covers closed systems, specifically low temperature hot water and chilled water systems. Also, it can cover closed condenser water circuits, and it can also be applicable to heating and cooling networks, what you might call district heating or heat networks, providing those are below 100 degrees C. So it would not apply to medium and high temperature heating systems. There are additional guidelines that apply to those, and I believe some of those are referenced in the text of BG50. Doesn't apply to steam systems. Again, there is separate guidelines for those. Doesn't apply to open systems such as cooling towers, which have entirely separate water treatment issues. It doesn't apply to domestic hot and cold water services. In other words, the hot and cold water that comes out of your taps doesn't apply to those. And it's not about Legionella control either. Legionella is not an issue in a closed system. Legionella is only an issue in open systems. I'll mention the linkage between this and BG29. Okay, I've just had another comment in the question box. Can you at least read out the questions in full? Yes, sorry, I didn't realise that the people watching wouldn't be able to see the questions in full. I'm not going to go back and read out the earlier questions, or well, not right now. I might have time at the end, but as more questions come in, I will read those out before I answer those. So it was always our intention to update both BG29 and BG50. In an ideal world, we would have done those at the same time. That would have been very difficult. It would have been quite a lot of work for us, and it would have been quite a lot of work for steering group members. There were quite a few members who were in common between the BG29 steering group and the BG50 steering group. So as it happens, there was a lag. So there was a short period of time when BG29 had been updated, but BG50 hadn't. Now we've got the 2021 editions of both, then they now should be fully in agreement with each other. The cutoff between them is either at the point of 3 months of regular operation, or if it happens first, practical completion. So the general idea is BG29 is about pre-commission cleaning. It's about everything that needs to be done to protect water quality up until you either get to that point of 3 months or the point of practical completion, whichever happens first. BG50 then takes over after that 3 months or that point of practical completion and applies throughout the life of a system. And it can also be applied to existing systems, including ones that perhaps haven't followed any particular guidelines up until that point. As you know, BG50 is in its 2nd edition now. BG29 is in its amended 6th edition now. So that includes all of the previous editions going back to way back when. All of those previous editions are available on the BSRIA website, even though they're superseded. It's because those can actually be useful reference for older projects. Let's talk about what's actually in BG50. We have changed the structure of it a bit. So some of the sections have been reordered. You're not going to find the same thing in the same numbered sections as in the 2013 edition. Some of the sections have been renamed. Water treatment was previously in 2 separate sections, one on chemical and one on non-chemical. Those have been merged together and additional information has been added there. And I'll go into a little bit more detail about that in a minute. There's also a couple of new sections, one on remedial flushing and cleaning, because this is sometimes necessary in older systems, and another one for fit outs and alterations, because obviously that's something that happens a lot too. There's also a number of appendices. First of all, we have case studies. There were case studies in the 2013 edition. Some of those have been kept, some of those have been taken out. We've also introduced some new case studies, particularly in relation to on-site monitoring of systems. So these case studies were very kindly contributed by steering group members. We've got a new section explaining more of the science behind how oxygen-induced corrosion works. I explained it earlier in very dummy terms of air plus water plus metal gives you corrosion. Appendix B goes into more detail about that. Some of the things that were weighing down some of the sections of the guide previously have been moved into appendices, particularly Appendix C and Appendix F. Biocides and antifreeze, those were in there before. Those have changed a little bit, not a whole lot. And then there's a new one on identification of NRB, which is nitrate or nitrite reducing bacteria. We've got a glossary that explains some of the key terms in the guide. So it's important as you're reading through the guide, when you come across a technical term, look it up in the glossary to make sure you have the same understanding as what our intention was. And then we've got a list of all the references that are used and a bibliography, which is further reading. So what have we actually changed? If we were to list every single change, we would be here for hours. Some of them were very small changes, generally making the guide more readable, more logically ordered, and clarifying points that had been confusing certain readers of the 2013 edition of the guide. But there's also some more major changes. One of them is the emphasis on this thing that we've called the water treatment program, because it appears that previously there wasn't a whole lot of clarity of what is the ultimate document that says, what are we doing in this building? So we said, well, there's got to be a documented program. We've called that the water treatment program. That would be planned by a specific person. So we've called that planners of water treatment programs. We haven't said who the planner of the water treatment program should be, other than that they should be knowledgeable and competent. As to what contractual relations they have, that is going to vary from project to project. We talked about maintenance water treatment specialists. So these are the people who will come into the building and offer advice on maintaining the water treatment, or there may be a water treatment specialist permanently in that building. What you will have is day-to-day system operators. These are people who are in themselves not experts on water treatment, but they're the people who need to make sure that the actions in the water treatment program are followed through on. And then as the building owner operators, ultimately the people who have financial responsibility for the system and obviously for the building as a whole. So it is in their interest to make sure that the water treatment is carried out correctly. Then in some cases, there are remedial system cleaning specialists where remedial work is necessary, which, as I mentioned, was in an appendix of the guide. We've got additional guidance on the frequency of sampling. So this is, it's expanded and clarified compared with the 2013 version. So there are different circumstances in which sampling is required, or when I say required, recommended at different intervals. Ultimately, it would be up to the planner of the water treatment programme to determine the frequency of sampling based on what type of system they have and what the issues in the system are. So without going into massive detail, it needs to be done every 2 weeks on a brand new system. Also, a system that has had any issues associated with it. Also, if it is seen that the water quality is deteriorating, perhaps from previous samples, then every month might be useful. In normal operation, if you have a system that is stable, has a good record of water quality, minimal water losses, every 3 months should be absolutely fine. And by the way, BS 8552 is the British standard on sampling from closed heating and cooling systems. It goes into a lot of detail about how to do the sampling, whereas BG50 is more about when to do the sampling. Other stuff that's changed, corrosion rates. We didn't have guidelines for corrosion rates in there before, so these have been added in terms of millimeters of corrosion per year. This is useful, especially now that we have very reliable ways of measuring corrosion rates, which I'll get to in a minute. The guidelines on microbiology have changed. So the important one here is total viable count, TVCs. So that's the main thing that should be monitored in systems. Pseudomonads is of interest. It's useful for information, but it was determined by the steering group that trying to set a limit for pseudomonads is always going to be problematic. SRBs, sulfate reducing bacteria, those shouldn't be detected at all. NRBs, that's another useful piece of information to know. But again, it was felt that we were unable to actually set a limit for those. We've got additional guidance in the guide on on-site testing. Now, this is something where we considered putting even more detailed guidance in, but actually we thought that really we don't need to go beyond this level. All we're really saying here is nowadays there are a lot of different tests available that can measure all kinds of useful system parameters. The best thing to do with any of these is go to the manufacturers of these kits, find out what they do, read the instructions on how to use their kits appropriately. That's why we didn't want to give more information. The manufacturers all have very good information on these things. There's some other techniques for monitoring that we didn't mention all that much in the 2013 guide. Ultrasonic testing can be useful for measuring pipe thickness. If it is suspected that there's been extensive corrosion, it's useful to know, are we getting to a point where this pipe work is going to fail? Also, endoscopy can be used. In other words, literally looking inside the pipe to see what the condition of the inside is. Also, these days there are various means of measuring corrosion rates. Reference components, corrosion coupons, these are things that can be removed from the system to actually see how much has been corroded on that small piece of metal. There's electronic coupon methods. So these are things that you can actually monitor the system from outside the pipework, similar with electrical resistance probes. With these new technologies, sorry, I shouldn't say new technologies, they've been around for a long time. But it's only recently that we've expanded the guidance on these. And I've got a picture here that was actually taken from one of the case studies where we have, I believe those are electrical resistance probes that are inserted into the pipework. I've seen another question coming in. So somebody has asked, leaving out upper levels for Pseudomonas and SRB is not consistent with BG29. Let me check up on that. I think our aim was to make it consistent. If we haven't done so, then I apologise for that. But I think I think we have made it consistent. Again, I will answer that question at a later point. That's going to require me looking in a lot more detail at the guide. Next question that has come in, you hinted to avoid oxygen ingress in closed systems, but does oxygen help to a certain degree? As another question, just to check tests and parameters against BG29, thank you. The aim should be to have no oxygen in the system. And some systems are actually designed even to be filled with deoxygenated water. Again, I will provide a more detailed answer to that after the webinar. On to the water treatment section of the guide. So we acknowledge that the previous edition of the guide was very heavily geared towards chemical water treatment. We've tried to include some other methods. Now, the thing that we're stressing here is chemical water treatment is not the only way of, it's not the only technique available. And systems will generally have a mix of different techniques available. Within chemical water treatment, we've defined that as including cathodic protection. We've got a lot more information on that now. We've got electrochemical water treatment in there. That is completely new information about there. And then the corrosion inhibitors, which has always been in there. pH management units, only a small mention of that, and scale inhibition. There's still a mention of that in there. We also have a separate section on bacteria and biofouling inhibition. And then physical water treatment, which is, these are really things that get stuff out of the system, things that get physical dirt, magnetic particles out of the system. So dirt separators, magnetic separation, disposable media filters. Also at the end, we've got deaeration. As I've said, it's important because oxygen in systems is probably the primary cause of corrosion. We've also got some guidance in here on external corrosion. This was a little bit controversial because this is actually nothing to do with water treatment. External corrosion generally occurs when you have moisture on the outside of the pipework. This could be moisture, say, dripping from somewhere. It could be moisture that has wicked through the insulation. Even occasionally, you might get situations where there is a leak in the pipe, which causes external corrosion in addition to internal corrosion. There's also a special kind of external corrosion called formicary corrosion that specifically occurs when you have phenolic foam insulation around copper pipework and when water gets into that phenolic foam insulation. We've included it here, fully acknowledging that it's not a water treatment issue, but because it's often mistaken for a water treatment issue. And ultimately, the people who are reading this guide are the same people that need to deal with both internal and external corrosion. Another question has come in, and it appears that that one has been answered. Yes, everyone's going to get a copy of the presentation at the end. We've got some additional guidance on minimizing oxygen ingress. As I've said, this is really important. Normally, in most systems, the system is initially filled with mains water. That's got oxygen in it. In other words, it's aerated. What usually happens then is that you get what we call flash corrosion. In other words, all the oxygen in the water is reacts with the steel surface of the pipes and causes a thin, harmless layer of corrosion. However, it's not always harmless. For example, if you have a large amount of water and hence a large amount of oxygen, but a small amount of steel, then all of that corrosion is going to get concentrated in one small areas, and that could cause damage. So for that and various other reasons, sometimes the fill water is deaerated before it's put into the system. And there are certain techniques and certain philosophies of water treatment that say we should always be deaerating the water. So now the elephant in the room. This is something that just kept coming up at the steering group meetings, which was pressurisation. As I've mentioned, oxygen in systems causes corrosion. But it's not just about the oxygen that comes in during the initial fill. It's not even necessarily about the oxygen that comes in during occasional maintenance and top up of the water. If you have constant or regular frequent ingress of oxygen, that is going to cause corrosion problems. And one of the reasons that that happens, not the only reason, but one of the reasons that this happens is because the pressurization in systems sometimes is incorrectly designed, incorrectly installed, not commissioned properly, perhaps has been neglected throughout the life of the system, perhaps the equipment hasn't been properly maintained. What sometimes happens as a result of this is that you get negative pressures in parts of the system. Then when you get the negative pressures, you get air drawn in at certain points, such as the air vents. So the vents that are there to let the air out of the system, in certain circumstances can let air into the system, which is exactly what you don't want. We're working on a new guide on this. We had the first steering group meeting about it. We're going to have another steering group meeting about it in January. We're hoping to get this published in March 2022. So perhaps some of you on the call might even be on that steering group. So it's really going through a whole project from design through all the way through to long-term operation of the system. What do we need to do to get pressurization right? It's not rocket science, but we felt that the industry really needed guidance on this, and I hope this guidance is going to come in useful for the industry. BG50 does mention pressurization, but we're talking about a couple of paragraphs here, not fine technical detail, which is what we're going to do in the new guide that we want to publish next year. So BG50 has been out for a couple of months now. I'm hoping that we're not going to need to update it for another few years. It was quite a big effort to update it. That was after 8 years. I don't know when the next update is going to be. It all depends what happens out in the world. We may get new technologies that need to be covered in the guide. We may have very different philosophies of water treatment in buildings, perhaps influenced by what is going on in other parts of the world. In the interim, inevitably, BSRIA guides do require changes. I do occasionally issue addenda to BSRIA guides. That is usually when we spot something that is perhaps incorrect or needs to be modified in a guide. We haven't done any addenda yet. If we do any addenda to BG50, we'll make sure we notify everyone who we have on our records as being in possession of a copy, and also we'll make it very clear on the BSRIA website that that's happened. Sometimes there's also clarifications that need to be made. So it's not that there's anything in the guide that's incorrect, perhaps just something that needs to be interpreted for a specific situation. Sometimes rather than doing an addendum, we'll do an FAQ on the BG50 page. So look out for those. Also, if you've got comments on the guide, please come and talk to me. I'm always glad to receive feedback. And on that topic, it appears that another question has come in. I'll read that out. What is the maximum TDS allowable from incoming mains before water treatment is required? The guide says high or similar, but doesn't give a number. Again, I don't have an answer for that one. I'll see if I can get you an answer for this one. So if you don't already have a copy of BG50, you can get it from the BSRIA website. If you're a BSRIA member, you can get that for free. The previous edition, BG50 2013, which is now superseded, that is still available because that may be useful for older projects, and I've given you a web link for that again. It's presently owned, BG50 2021 is only available as a PDF. We can take orders for branded hard copies. So this would generally be if a company wishes to order a batch of hard copies with their logo on it to present to customers, for example. But in general, we're moving away from hard copies and just sticking with PDF for now. Another question has come in. Does the guidance take into account the treatment or initial use of small systems? There is no size limit on the application of BG50, but it is intended to, or rather it is not intended to apply to, say, the heating system in my flat where I'm sitting right now. I'll just read a little more of that question. Some systems that are installed a little more than a large domestic system with multiple metals and a very small budget to work with. Previous advice has quite often been impossible with the costs that are involved compared to the cost of the system. Again, I think that's quite an involved question. I'm not going to be able to answer that one. I may have to look at that into that one in more detail. Maybe ask members of the steering group for clarification on that point. So thank you very much for that question. We'll get you an answer to that, but it may take a little while. Just very quickly mention some BSRIA training courses that we do. So we have a BSRIA course on pre-commission cleaning. That's taking place in January next. There's also a couple of courses that are run by WMSOC, the Water Management Society. We advertise these on the BSRIA website, but they're actually not run by BSRIA, so that's why I've given you the WMSOC links. Also, there's quite a few dates available for these, so I haven't attempted to list all the dates. Also, we can do in-company training for any of these courses. Final thing I'll say about BG50, we had help from sponsors. Obviously, updating these guides is quite a long process. It's quite an expensive process. We wouldn't have been able to do it without these sponsors. So thank you very much to all the sponsors. That's it for me. And I see the note there that somebody's put in saying there is a new British standard coming out for domestic systems. Thank you. I seem to remember hearing about that. I'll find out what that standard is. I'm sure I can find that out easily, and I'll put that in the answers that I distribute after this presentation. Thank you very much for listening, everybody. You have my contact details there if you want to contact me with more questions. BS8693, thank you. Three separate people have said BS8693, so I think safe to say that is the one. Does anybody know when BS8693 is going to come out? I've got a feeling maybe some people on the call might even be on the committee for that standard. If not, don't worry about it. I'll try and find out and answer that question for everybody. Thank you very much, everybody. Just in close, Pam, is there anything that you would like to say?
I'd like to just, there was a couple of questions that I can offer some explanation.
That would be brilliant.
There was one about boron. Just trying to find it. But basically boron covers a multiple of things, and it's also classed as a biocide as well. So what the issue around boron is that it's considered on a hazard, too hazardous to use list, probably for the environment. So so that's likely not to get approved through, for example, the biocide directive, and I think it's also from a chemicals point of view, it's also on a hazardous list as well. So so although it still gets used, it's starting to be referred to as a hazardous component, and there is comment about that, a brief comment about that actually in the BG50. So that's trying to elaborate about the boron. There is a question about plastic and how it can transfer oxygen. There is also some comments in the BG50 about that, and there's a statement in table 4 that covers saying that, you know, there is a risk that oxygen can move through, so you do need a barrier. So there are some comments in that about that as well. and there were, I'm just scrolling down the questions that I can answer straight away. The comment about where is it? The Pseudomonas and TVC, leaving out upper limits. Oh, Paul O'Brien asked this. Leaving out upper limits for Pseudomonas and SRB are not consistent. It does state SRB are not present. So it is consistent with BG29. The reason that Pseudomonas has been put down as for information only is because very often for an ongoing system, if you basically you're using the TVC and potentially Pseudomonas as an indicator of what's going on, so what the water quality is like. So it was agreed that we could use TVC as which is total viable count, as an indicator of whether or not you've got bacteria in there. And usually Pseudomonas, being the most popular species in water, would be picked up by the determination of total viable count. So the emphasis basically is more on control. So if you've got a low level of TVC, then it is assumed that Pseudomonas will also be low, because they're probably, to be honest, they probably contribute about 90% of a total viable count anyway. So if you are detecting a high TVC, then it would be sensible to look for Pseudomonas. But the decision was to refer to total viable count. And it doesn't mean that you can't analyse for Pseudomonas. It's a water treatment specialist decision as to whether they want to include that. But what you would then be looking is that it is no worse than the total viable count that you're finding. So that was the emphasis. So it's more about once you've got your system at handover in control microbiologically, and you are regularly monitoring, the TVC should be a quick enough alert to indicate whether or not the system is going out of control. And if it is, then you would need to, rectify it anyway. And part of that would be, the detection would be Pseudomonas anyway. So I think that's probably the most I can answer at the
moment. It looks like we've had a lot of people commenting on the question about water treatment for domestic systems, but I think rather than read out these questions or read out the answers, I think I'm going to do some investigation on my own, find out what the status of these various standards are, and try and provide a single definitive answer. And I'm sure some people from the steering group will help me with that. Excellent. Does anyone have any more questions or comments that they would like to make? Well, we've been going for over 45 minutes now, so we have run over just a little bit. I hope you don't mind. Thank you very much, everybody. I hope you found this useful. Like I said, please be in touch if you've got any more questions about BG50 or anything to do with BSRIA publications or anything that BSRIA does. Another question has come in. Table 4 in BG20, I'm assuming you mean BG29, gives a level of 1,000 CFU as an upper limit, not 10,000 CFU. I think this needs to be reconsidered. Paul, again, I'll look into that. Yeah, if there are any inconsistencies, then those definitely need to be ironed out. But before commenting on that, I'm going to look into that in detail and just check 100% for sure whether we've got this right or not. All right, thank you very much for everybody. I am going to end the broadcast.